In the second part of this application, we start with the same old IPIsValid function to check the format of the IP address entered by the user. Then we silently ping that address to verify if it is reachable using subprocess.call. If it's not, then the program will exit so you can fix the reachability issue. So we use sys.exit here and here. After the function is defined, then we call it to complete this step. So try IPIsValid, except keyboard interrupt. If the user presses Ctrl+C, then the program will be aborted. Next, let's skip this empty list I defined for now, and let's remember the same SNMP get function we talked about in the Python networking with SNMP lecture. For a detailed review of this function, you should revisit that lecture. However, I'm going to walk you through the function real quick. First, we have to create an SNMP command generator object, this one right here, that is simply an instance of the command generator class. Now, using this object, I'm calling one of the methods in the class, nextCMD right here, that performs the SNMP getNext request and then returns a response. The nextCMD method returns a tuple consisting of error indication, error status, error index, and var bind table. This is actually a tuple assignment. The last variable will actually store the SNMP object name and the result of getNext. In between parentheses, we have some arguments that we passed to this method. The first argument is there for security reasons, and it is actually the SNMP community string, which in our case is stored in the com variable, this variable right here, and takes its value from the user input, that is when we type in public at the prompt. The second parameter is the SNMP transport object, which takes care of the communication to the router. Here we have to enter the IP address of the router, which is also entered by the user at runtime and stored in the IP variable right here. We also have to specify the UDP port on which the router listens for SNMP requests. This is 161. Finally, the third parameter is the SNMP object identifier. Now moving to the code below, this is where you extract the SNMP object values in a nice and readable format from the tuples returned by nextCMD. For detailed explanations about the list and string methods I used here, please refer to the Python networking with SNMP lecture. With minor differences, the same methods are applied to extract each parameter we are interested in. Finally, we will populate the OSPF devices dictionary using the values we just got from the router and then append the dictionary for that device to the OSPF list we defined up here. And this is where we're doing the appending. Now let's uncomment this print statement right here and run the application to see the list. So let's save it and let's run it. Debian 192.168.2.101 public. For now we have just a single dictionary in the list. So notice the dictionary right here. The one corresponding to the IP address entered by the user, R1's IP address in our case. So we have the hostname, R1, the OSPF router ID, 1.1.1.1, the OSPF router ID of its neighbor, and finally the IP address of that neighbor. Next, we will see how to obtain the same information from the rest of the routers in the network.